Let's look at B. Probability even. So that means what are even numbers in a dice?
2, 4, and 6.
Yeah. So how many of them are there?
3.
3, right? So there's 3 of them. And then how many total outcomes in a dice? Always 6. Yeah. So this means 3 over 6 reduces to what? 1 over 2.
Okay.
What about the last one? Less than 3. So again, we know there's going to be 6 total. How many of them are less than 3?
2.
2, right? 1 and 2. And what does 2 over 6 reduce to?
Is it 1 over 3?
It is 1 over 3. So there we go. Well, what does 1 over 3 mean? It means there is a 33% chance, okay, that you roll a number less than 3 when rolling a dice.
Okay.
Good. So what's going on here? So this girl, she spun her spinner, okay, and this is what she got. Let's analyze this. What's going on here? Oh, that's too big. All right. So on our spinner, there are 10 numbers, okay? And when she spun it 80 times, she found that it landed on number 1 6 times, number 2 6 times, number 3 8 times, and as such. So it landed on number 9 14 times. So these are called the experimental probability. Okay?
Okay.
So this is the probability that you get. But that doesn't have to be what is expected though. So for example, when you roll a dice 6 times, yeah? Roll a dice 6 times, we know the probability of getting a face is 1 over 6. But there could be an instance where you got all 6s, right? 6s each time. So that means you didn't get this, 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 or this. So that is an experimental probability. Okay? That's very unlikely to happen, but it can happen, right? Like winning a lottery or something like that. So experimental probability is the probability you get by actually doing it, okay? Whereas theoretical probability is what is expected. So if you roll a die 6 times, theoretically, you'd expect them to all be rolled at least once.
Okay.
So the first question is asking you, the experimental probability of spinning a 3 is 8 out of 80 or 1 out of 10. Yeah? So out of 80 times, it landed on 3 8 times, so it's 1 out of 10. Which numbers had greater experimental probabilities than 3?
Um, 7, 8, 9, and 10.
Yep, that's right. So part B, what is the theoretical, yeah? What is the theoretical probability of spinning each number? So if you have a spinner that has 10 different numbers, yeah? Let's say you have a spinner that you have 10 different numbers, you roll it, you spin it once, yeah? What's the probability that you get a 10?
1 out of 10.
1 out of 10, right? So that's the answer to B. The theoretical probability of spinning each number is 1 out of 10
All right.
because there's 10 total outcomes and 1 chance for each of them. Yeah.
Mm-hmm.
Alrighty, let's look at this. So probability you can use in real life as well. Like when you're just playing a game or something. Higher probability is good. Well, I guess for good outcomes. So let's look at this. You toss a coin. What's the probability that you toss a tail?
One out of 2.
Yeah, good. 1 out of 2. Here, you have 5 different numbers. What's the probability that you spin a 4?
1 out of 5.
Yeah. Drawing a black card. Now, cards are a big thing in probability. In a deck of cards, okay? In a deck of cards, there are 52 in total.
Uh-huh.
So, and then half of them are black, half of them are red, okay?
Mm-hmm.
These are called suits. So you have diamonds, you have hearts, you have spades, and you have clubs, okay? But in total, there's 52. Half of them are black, so 26 is black and 26 is red. So this one's asking you, what's the probability of drawing a black card?
Mm-hmm. 26 out of 52.
Yeah, what does that reduce to?
Um, $13 over 26.
Yeah, once more, try once more. It's gonna reduce once more. 26 is divisible by 13.
1 over 2.
Yep. So you can draw a black card half the time, or you're expected to draw a black card half the time. Okay.
Mm-hmm.
D says rolling an even number. Is that supposed to be from this diagram? So there's only 3 faces to this, I see. Yeah.
Mm-hmm.
And then there are even numbers in 2 of them. Yeah.
Mm-hmm.
And in the bottom one, there's just odd. So what's the probability of rolling an even number?
Wait, like, are there 2 places for
Yeah.
odd numbers too?
So there's only 1 place for odd and 2 places for even. Actually, no. There's even
like, the
numbers in one of
bottom-
them, yeah.
I mean, I guess it's just hiding the bottom.
Yeah. So that means you're gonna roll an even number each time, right? No matter what you do.
Mm-hmm.
So it's 100%, so that's a 1.
Okay.
Is this talking about this thing? Or is it talking about like a dice? If it was a dice, then what would be the probability of rolling an even number?
3 out of 6.
You can reduce that. Usually you want to reduce it.
1 out of 3.
Yeah. I was going to be spinning an odd number. So what's the probability that you spin an odd number here?
3 out of 5.
Yep. Drawing a red card less than 9. So that one can be a little bit tricky. So if you look at the red cards, right, you can draw any one of these, yeah? So you can go from
17 out of,
probably not 17, probably going to be an even number, right? 1 to 8 on the bottom and 1 to 8 on the top. Yeah?
oh,
So that means there's 16. And then in a deck, there's always 52 cards. You can reduce to 8 over 26. 4 over 13 would be the final answer that you can reduce it to. Okay, G, let's say they're talking about a dice here, because I think one of the faces is missing for this guy. Rolling a number greater than 1 on a standard dice.
5 out of 6.
Yeah, that is right. Let's look at this. Now this is a dice that has 12 sides. These are the experimental probabilities, okay? Question 1 is saying which experimental probability matches the theoretical probability exactly? So there are 12 numbers, yeah? If there are 12 numbers, what's the probability you roll an odd number on one try, in one try? How many odd numbers are there? Between 1 and 12.
6.
Yeah. Okay. Is 6 is to 12 the exact same thing as 18 to 48? Are they the same thing? Reduced?
Yes.
No, it's not. 12 times 4 is 48. Yeah. 6 times 4 would be 24. They're not the same thing.
Oh, okay.
Okay, this is the, and so in terms of, can just multiply this by 4. So it should have been 24 over 48, not this. Okay. What about this one? If you roll the dice once, what's the probability that you get a number greater than 8?
4 out of 12.
Yeah. Now is 4 out of 12 the exact same thing as 16 out of 48?
Yes.
Yes, it is. So that's our answer for A. Okay.
Okay.
What about the number 9? If you roll a dice once, what's the probability that you roll a 9?
Just once.
Yeah, 1 out of 12, right? So it's asking you which is the furthest. This one's the furthest. Okay.
Okay.
because that would be 4 out of 48. So that's pretty far. So in a bag, there are 10 red marbles. Okay.
Mhm.
So let's say this is the bag, and then there are 10 red and 6 green. So total there are 16, yeah?
Mhm.
So if you pluck out a marble, what's the probability that it's a green?
Um, 6 out of 16.
Yeah, exactly, 6 out of 16. And you can reduce this to 3 out of 8. Okay.
Mhm.
B, what's the probability that it is purple?
0.
Yeah, good. There are no purple in there. What's the probability that it's red or green?
It's just 16 out of 16. So like
Yes.
100%.
Yes. So that's a 1, okay?
Mhm.
Yeah, 1 means 100%.
Okay.
Let's do this one.
Okay.
So there are 6 blue blocks, okay? So you can just count them as marbles. There are 6 blue. What else is going on here? There are 4 red and there are 2 green.
Okay.
So how many are there in total?
12.
12. So what's the probability that you pluck out a blue marble or whatever block?
6 out of 12.
Yeah, good. So that is, what does that reduce to?
1/6.
1/2, not 1/6.
Oh, okay.
What's the probability you pluck out a red block?
4 out of 12.
What does that reduce to?
2/6.
Once more.
Is it 1/3?
Yes. And what are the last one? Green.
2 out of 12.
Yeah. And it's going to reduce to
1/6.
Yep. And there we go.
Okay.
So this one, very similar, but now a little bit different at the same time. So there are 25 blue, 10 red, 10 yellow, 5. So there are 50 in total. Okay. 50 total. What's the probability of plucking a blue marble out?
Um, 25.
25 over what?
50.
Yes. What does that reduce to?
5/10.
Once more.
1/5.
1/2. Right?
Oh,
You said
okay.
5/10. That's going to be 1/2. 5 goes into itself once and into 10 twice. So the probability of plucking a blue marble is 50% or 1/2. Yeah.
Mhm.
Now, if you completed 500 trials, let's say you plucked out 500, or you put it back and then you plucked it out. You put it back, you plucked it out. How many blue marbles would you get out of 500?
Um. $250 times.
Yeah, good. What about 75?
750. Wait.
Wait, no.
No.
Can be more than that, right?
Mhm. Um.
Half the time, right? It's going to be half, so 37.5.
Okay.
500, 250, so whatever the trial is, half the time you'd expect it to be a blue marble. Yeah?
All right.
Suppose that you toss a coin. Okay, let's toss a coin. So this is the coin, it's been tossed, yeah? What are the outcomes of a coin toss?
Um.
You either get a head or you get a tail, yeah?
Mhm.
So what's the probability of getting a head if you toss a coin once?
1/2.
Yeah, same thing for the tail, right?
Mhm.
Now, after you've done this, let's say you land on a head and then you roll a dice, right? So you have 1, 2, 3, 4, 5. You can also get a 6. So what are the probabilities of all of these?
1/6.
Yeah. And the same exact same thing in the bottom as well. You say you get a tail, and then you can get 1, 2, 3, 4, 5, 6, yeah?
Mhm.
The question's asking you, what is the probability of getting heads and an even number? So you go heads first, and then you go to 2, 4, or 6, right? So what does this mean? What does this mean? This means this, okay? You either get a head and a 1, you get a head 2, head 3, head 4, head 5, head 6, yeah?
Mhm.
Those are your outcomes. Or you get a tail 1, you get a tail 2, tail 3, tail 4, tail 5, tail 6. How many total outcomes?
12.
12, right? How many outcomes with a head and an even number?
3.
Yeah, exactly. And what does 3/12 reduce to?
Um. 1/4.
Yes. Right, there we go, 25%. Okay,
Okay.
that's the answer to A, 1/4. What is the probability of not getting heads and an even number? So now again, the total outcomes are 12, yeah?
Mhm.
So not getting heads,
9.
Yeah, exactly. 9 out of 12. What does that reduce to?
Um, 3/4.
Yeah. And now notice these two adds up to 1.
Mhm.
Because initially we did this, this, and this, and then in the other one we did everything else. Yeah, and the total
Mhm.
probability will always add up to 1. So for part B, you could have also done this, 1 minus 1/4. Because the total is 1, yeah? You
Mhm.
take out heads and an even number, then you get not heads and an even number. So that's going to be 3/4.
Okay.
So now we're combining probabilities, okay? It's a little bit different. I mean, a little bit trickier, but it's not that bad. So how do we draw the T diagram for this one? We have a dice and then we have a spinner. So let's do this for a dice first. We roll a dice. What are the outcomes?
1 through 6.
Yeah. And now what you need to do is, after you're done rolling the dice, you're going to roll the spinner, and that has 4 different probabilities, yeah?
Mhm.
What is that? Green, purple, orange, yellow. Yeah, see all of them.
Uh-huh.
So you basically have 1 with green, purple, orange, and yellow. Then you have 2 with the same thing, 3 with the same thing, 4 with the same thing, 5 with the same thing, 6 with the same thing.
Mhm.
So you understand this? This means you either get 1G, yeah? This is an outcome, this is an outcome, this is an outcome, this is an outcome, or 2G, 2P, 2O, 2Y, like that, okay?
Mhm.
How many total outcomes are there?
Um, 24.
Yeah, good, perfect. There's 24 total. Let's answer the questions. 3 and yellow. So that means what's the problem? How many outcomes with 3 and Y?
Just 1.
Just 1, yes. So that's the answer to A, just 1 out of 24. Let's look at B. Anything except 3 and yellow.
So 23 out of 24.
Yes. 23 out of 24. Part C is saying a number that's greater than 3. So we ignore all of this.
Mhm.
4, 5, 6, and purple. So we want 4 purple, 5 purple, and 6 purple.
So just 21 out of 24.
Not 21. So you can
Oh,
only
3 out
have
of 24.
3 out of 24. What does that reduce to? 3 out of 24.
Um, 3/8.
Yeah. Actually, no. 3 out of 24 is 1/8, not 3/8. 1/8.
okay.
Yeah, 1/8. So this one. Create a tree diagram to show all the possible outcomes for tossing 3 coins. Okay, 3 coins. So first coin, what are the outcomes?
Heads or tails?
The second coin, what are the outcomes? Either you get heads and then you get heads again, or you get heads and you get tails, yeah?
Mm-hmm.
Or you get tails and then you get heads, or you get tails and then you get tails. What about the third coin toss?
Um,
So same thing, starting from the second toss, yeah?
mhm,
You get heads and heads, and then you get heads, or you get tails, like this.
uh-huh.
So what does this mean? This means you can either get a head, head, head. Yeah, what about this one?
Heads, tails, and tails.
No, no, heads, heads, tails. Heads, heads, tails.
Oh, okay.
What about this one?
Heads, tails, and tails.
Heads, tails, and heads. Okay, the top one.
Mm-hmm.
Now you get heads, tails, tails for the fourth one.
Oh, okay.
What about this one?
Tails, heads, and heads.
Yeah, good. The next one?
Tails, tails, and heads.
No, tails, head, tails, right? This one.
Oh, okay.
Then you have TTH, and then you have TTT. Okay, there we go.
Okay.
So total, there are 8 outcomes. See,
Mhm.
these are all the possible outcomes. Now this one's saying, what's the probability of getting one tail? So how many of these have one tails? You have this one, you have this one, you have this one, and that's it.
Mhm.
So what would be the answer? Probability of getting one tail.
3 out of 9.
8, there's 8, right?
8. Okay.
5, 6, 7, 8. What about B? 2 or 3 tails? So 2 tails. So this one, this one, this one, and then it says 3 as well. There you go. Right?
Mhm.
So what is that possibility?
4 out of 8.
Yeah. And that is 1 over 2, not 4 out of 2, 1 over 2 when you reduce that.
Okay.
What is the probability of not getting any heads?
Just 1 out of 8.
Yeah, good. And there we go. All right, tree diagram. Very
Mhm.
useful. Right, using this, you can do any of these questions.
Okay.
What about this one? This one's a little bit of a biology question here. Offsprings. Calculate the probability of having 3 boys in a family with 3 children. So let's say they have the first child, all right? What can it be?
A boy or girl?
Boy or a girl, exactly. And let's say it was a boy first, then again it becomes a boy or a girl, and then it becomes a boy or a girl, right?
Mhm.
Now third child, either you get BBB or you get BBG, or you keep going like this. How many
Mhm.
outcomes?
Um, 8.
8, right? And which one has 3 Bs? How many of them have 3 Bs? Or 3 boys?
Um, just 1.
Yes. So 1 out of 8. Okay,
Mhm.
so you see this?
Uh-huh.
If you had just 2 children, then you'd get 2 out of 4, yeah, boys.
Mhm.
So that's why some people have a lot of children, because eventually the odds will, I mean, let's do one more actually. Let's say they have, I'm gonna ask you, 4 children. What's the probability of getting all boys?
Um,
Look at the number of outcomes. One boy, there was 2 outcomes. Yeah, sorry, the first child, 2 outcomes. Second child, there was 4 outcomes. Third child, there are 8 outcomes. Fourth child, how many outcomes would there be?
um,
It's just
12.
doubling. No, not 12. It's doubling. Double. 16, right?
10? Oh, 16. Okay.
16, because you get BG here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It doubles. So what's the probability you have all boys out of 16?
Just 1?
Just 1. And the same probability for girls as well, right? The probability that you get G, 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 4 girls is 1 out of 16.
Mm-hmm.
Can happen. I mean, but unlikely to happen. That makes sense?
Mm-hmm.
Let's try doing some of these. What is the theoretical probability of each event? Drawing a queen from a standard deck of 52 cards. So how many queens are there in a deck?
4?
Yeah, exactly, one of each suit. So what would that be?
4 out of 52?
Yes. So can you reduce this?
1/13?
Yes. Rolling a 1 using a standard die. Die just means like a dice. 6-sided dice.
1 out of 6?
Yes. Spinning a 9 with this spinner.
0?
Drawing a black card from a standard deck.
1 out of 2?
Yeah, good, perfect. I'm gonna ask you something difficult. From a standard deck, okay, there are something called face cards, and those are the jacks, yeah, not the joker.
Mm-hmm.
I write this upside down. And then you have the queen, and then you have the king, okay?
Mm-hmm.
These are called face cards.
Uh-huh.
Not a face card. Ace is not a face card. There's no face on the ace.
Okay.
On jack, queen, and king, there they have faces. So what's the probability you pluck a face card from a standard deck?
Is it 4/13?
Yeah. Actually, is it 4? So there are 4 suits, yeah?
Uh-huh.
So that means there's 12 total, right? 12 out of 52, like that. Yeah, that is that 3 or 4? No, it's 3 out of 13.
Oh, okay.
All right, 3 out of 13.
Mm-hmm.
So they spun this 36 times. There are 9 numbers. Part A is asking you, it's gonna be one of these, okay? It's just options. So one of the answers up there is gonna be right. The theoretical probability of spinning an odd number.
Um, 5 out of 9?
Yeah. 1, 2, 3, 4, 5, right? So this one's done. The theoretical probability of spinning purple.
1/9?
An unexpected experimental probability of spinning blue. I guess they would both be right for in this case.
mhm.
Let's do D first, and the answer for C would be obvious. Experimental probability of spinning an even number.
I mean, D would be more likely for like.
So what's the theoretical probability of spinning an even number?
4 out of 9.
4 out of 9, right? We have an 18, so I guess they would both be right. It's 8 out of 18, yeah?
Mhm.
So I guess for these, you can pick any one of them. Because it's 8 out of 18, so both of them are different. And this one, spinning blue, is 1 out of 9, so they're both different as well. So C and D, you can pick one of them.
Mhm.
Oh, this is like a communication problem. You don't really have to do any math. So this guy rolled it 600 times and this guy rolled it 6 times. In which case is it more likely that the experimental probability is closest to the theoretical probability?
Would it be the same?
Nope. One of them is more than the other.
600?
So the more trials you do, the more closer it's gonna be to the theoretical.
Okay.
Suppose that you're going to roll a 4-sided dice, okay, our die, and a standard 6-sided dice, okay. Oof. So let's first roll a 4-sided. What are the options?
Of just getting a 1, 2, 3, or 4.
And after this, you're gonna roll a 6-sided dice. So what are the options?
Getting 1 through 6.
So you can either have 2, 3, 4. You can either have 1, 2, 3, 4 on the first, yeah? Then you can have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Actually, what would be better would be if I did it like this. Because part B is asking us, yeah?
Mhm.
Find the sums, right? So let's do it like this. So you have this second dice up top. And then you have the 4-sided dice down here.
Mhm.
Okay.
Okay.
Now we're just gonna add them up. Dun, 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 dun. So 1 plus 1 is 2, 3, 4, 5. Yeah. 3, 4, 5, 6, 4, 5, 6, 7. What would this be? 5, 6, 7, 8. 6, 7, 8, 9, and then 7, 8, 9, 10. All right. Everything in the middle is a sum. Okay.
Mhm.
Now let's look at part B. What's the probability? How many outcomes? Let's first find the number of outcomes here. What's the total number of outcomes?
24.
Yeah. So what's the probability that I get a sum of 2?
Just 1 out of 24.
Yes. So that's 1 out of 24. I. What's the probability you get a sum of 3 or 4?
5 out of 24.
Yeah. And it says neither 3 nor 4. So you can either count the remaining or you can do 1 minus this.
So 19 out of 24.
Yeah, good. Perfect. All right.
Mhm.
There we go. That's all there is to this one. What do you think
Okay.
about probability?
I think it's kind of easy.
Okay, that's good. Easy is always good. What are you doing in school for this so far?
We finished like integers, and we just finished doing like order of operations for like negatives and positives.
How did you
But
find
I'm
it?
not sure. I think it was pretty easy.
Oh yeah, that's easy is always good. That's what I want to hear.
Mhm.
Okay, let's call it a day here then. I'll see you on next week.
All right, thank you.
All right, take care. Bye-bye.